Very good morning, everybody. This is Vinu Venkatesh, and you're back with me for another session in mathematics on behalf of the SAI Education for Competitive Examinations. Today, we're going to discuss time and distance, and I will be showing you the lectures in two parts, that is part 1 and part 2, because we have quite a few problems to cover. So let's start. So first and foremost, in this topic, time, distance, and speed, one of the basic rules is to make sure that all the units given for time, distance, and speed are uniform. What do I mean by that? Meaning, if the distance is given in kilometers, the speed should be kilometers per hour and the time given should be in hours. If the distance is in meters, then the speed should be in meters per seconds and the time should be given in seconds. Okay? We always have to make sure we also have to convert. So, what are the conversion criteria? 1 kilometer is equal to 1000 meters, 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds, 1 hour is equal to 3600 seconds. Okay? So let's look at the first question. A car driver travels to the plane from the hill station, which is 200 kilometers apart, at an average speed of 40 kilometers per hour. So distance is 200 kilometers, speed is 40 kilometers per hour. So it's fine. In the return trip, be very careful. Return trip, he covers the same distance, obviously, at an average speed of 20 kilometers per hour. This unit is also the average speed of the car over the entire distance of 400 kilometers is how much? That's the question, right? So do you know how we got 400 kilometers? It is 200 kilometers from the plane to the hill station. Sorry, from the hill station to the plane, and 200 kilometers obviously from the plane to the hill station. So total 400 kilometers. Now they're asking you for the average speed. So the first tendency when you see this question is simply to take an average of the speeds given. That is 40 and 20. So average of 40 and 20 is how much? It is 30. That is not correct. That is wrong. See, they have given you a formula here to calculate it. This is how you should do it. But I would like you to understand the question and then arrive at the same answer. That I'll show you how to do. Okay, so whenever you try to solve a problem, please first write down the information that they have given you. So distance is 200 kilometers. S1, that is the speed of the, excuse me, the first leg of the journey is 40 kilometers per hour. And speed 2 for the return trip is 20 kilometers per hour. Okay, so time taken for the first part of the journey is distance divided by S1, which is 200 kilometers divided by 40 kilometers per hour. When you arrange it properly, you will see that kilometers get cancelled and you get a time of 5 hours. Okay, similarly, time for the remaining part of the journey, remember the distance is the same, so I haven't changed it, so it is still D, but divided by the speed taken at this time, which is 20 kilometers per hour, or speed 2. Once you do the calculations, you will see that you get 10 hours. So the total time for the entire journey, that is capital T, is 5 plus 10 or 15 hours. Total distance, capital D, already given, 200 plus 200, which is 400 kilometers per hour. So what is the speed taken? Average speed for the entire journey is capital D divided by capital T, which is 400 kilometers divided by 15 hours, which is 26, and 2 by 3 kilometers per hour. And that is the answer that is given to you. So I prefer that you work out the problem and get the answer. You can also use a formula that was given in the lecture notes, but I want you to understand the question instead of simply memorizing that formula. Okay? Okay, so let's move to question number 2. A cyclist covers a distance of 750 meters in 2 minutes and 30 seconds. Okay, so distance in meters, speed in minutes and seconds, so it's fine. What is the speed in kilometers per hour of the cyclist? We simply have to convert it. Okay, we need not calculate the time. So let's see how to convert it. It's very, very simple. All right, now look. Again, I just want you to work out this problem more than anything else. So 1 minute is 60 seconds, correct? So 30 seconds is equal to half a minute. Therefore, the time that we are given, the time that we are given is 2 minutes and 30 seconds, which is nothing but 2.5 minutes, which can also be written as 5/2 minutes. All right. 1 hour we know is 60 minutes. Therefore, 5/2 minutes is equal to how many hours? It's 5/2 divided by 60, which is equal to 5 divided by 120 hours. Right? Now, to calculate speed, the formula is distance divided by time, which is equal to 0.75 kilometers divided by 5 by 120 hours. Once you cross multiply and simplify, you will get 18 kilometers per hour. Okay, very simple, and that's what even they have done, but they have done it more compactly. I would prefer if you do it by yourself using this kind of a working, so that you'll always understand. All right. Okay, now let's move to question number 3. A train 300 meters long is running at a speed of 54 kilometers per hour. In what time will it cross a telephone post? Okay, see, whenever you get questions about crossing a telephone post or crossing a man, and they're asking you what time, it is nothing but the length of the train divided by the speed. Okay, whenever you're given train questions and they give you the length of the train and its speed, and they ask you how long will the train take to cross a man or a post, then it is nothing but the length of the train, which should be taken or considered as a distance divided by the speed. So this you will get after converting. You will get it as 20 seconds. It's 300 meters. You have to first convert this into kilometers, which would be nothing but 0.3 kilometers. That is 300 divided by 1000. 0.3 kilometers divided by a speed of 54 kilometers per hour, which will give you which will give you, after conversion, it will give you 20 seconds. I'm not showing you the calculation because we have done similar problems. I want you to do it by yourself now. All right. Okay, let's look at number 4. A train 360 meters long is running at a speed of 45 kilometers per hour. Okay, so distance is 360 meters, speed is in kilometers per hour. Okay, in what time will it pass a bridge 140 meters long? So in number 3, we were only given the length of the train and the speed and asked how long it will take to pass a post. But now they're asking how long it will take to pass a bridge of 140 meters. In such questions, we always take the length of the train plus the length of the bridge as the distance, which in this case is 360 plus 140, which is 500 meters. Okay, that divided by the speed in the uniform unit will give us the time taken. So here they have taken distance of 500 meters divided by speed of 45 kilometers per hour, and this is a conversion factor 18 by 5 to give you 40 seconds. Instead of using this 18 by 5, you can follow the steps that I showed you in one of the previous examples, where we take 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds. So how can you convert it? Or simply you take the distance as 0.5 kilometers. So it would be 0.5 kilometers divided by 45, which will give you the time in hours. When that is converted into seconds, it should give you 40 seconds. Okay, you can do it. So it's very simple. So always remember, when they are giving you train questions and they're giving you the length of the train and the speed of the train and asking you to calculate the time that the train will take to cross a pole or a post or a man, then it is always the length of the train divided by the speed. Okay, units should be uniform. But if they ask you how long will that train take to pass a bridge or a platform whose length is given separately, then you will take the distance equals to length of the train plus length of the bridge or length of the platform or length of the river, anything like that. That will be the total distance divided by the speed is equal to the time that the train will take to pass the bridge or the platform or the river. Okay, that is the big. Okay, let's move to number 5. A man is standing on a railway bridge which is 180 meters long. he found that a train crosses the bridge in 20 seconds, okay, but himself in 8 seconds. Find the speed of the train. Okay, this problem you have to work out a bit. Okay, how do you work it out? Let's start. So let the length of the train be equal to x meters. All right, therefore, as per this question, what is this question saying? Let's go back, sorry. Find the speed of the train. So the speed of the train obviously is the same because they have not mentioned anything about it, right? So assuming that the speed is the same, we can equate the two scenarios, right? What are the two scenarios? The question says the time taken to cross the train and the bridge of 180 meters is 20 seconds, correct? So let the speed of the train in this situation be equal to 180 meters plus x, which is total distance, divided by 20 seconds. This is the same as the speed of the train when the train crosses the man himself, right? Which they say is done in 8 seconds, isn't it? So the equation would be, so the speed in this case would nothing be the length of the train divided by the time taken to cross the man itself, which is 8 seconds. Remember, we discussed why it is 180 plus the length of the train in the previous question. It's the same logic. Once you solve this equation and simplify, you will get x, or the length of the train, as 120 meters. Is it correct? Absolutely, it is correct. It is 120 meters. Now they are asking us to find the speed of the train. Once you find the length of the train, substitute this 120 meters in any of these two equations and you will get the speed as 54 kilometers per hour after conversion. We have talked about conversion and accordingly we must go ahead. All right. Okay, so let's move to question number 6. Now, question number 6 and 7 are important because in this case you have to memorize certain formulae. Okay. So two trains, 137 meters and 163 meters in length, are running towards each other on a parallel line. They are running towards each other, meaning they are coming like this. One is coming from this side, the other one is coming from this side. Another way that they put this in the exam paper is they are running from opposite directions. That is, one is coming from here, right? The other one is coming from here. They are running towards each other, but they are coming from opposite directions. So they mean the same thing. Okay, one at a speed of 42 kilometers per hour, and the other one at 48 kilometers per hour. Now look at the units. Be careful. In what time will they be clear of each other or cross each other? That is, they will just cross each other from the moment they meet. Okay, so in such questions, there's a formula that we have to follow. So whenever we are asked to find the time that the trains will cross each other when they are coming from the opposite direction, that is when they are running towards each other, we add the lengths of the train and divide by the speeds of both the trains. Okay, if it's the same direction, which we will see in question number 7, we will follow another formula, but forget that for now. We will look at this one. So add the lengths of the two trains, which is 137 plus 163 is 300 meters. Add the total speeds, which is 90 kilometers. After conversion, you will get 12 seconds. Okay, instead of using this, I would say you go by our way of doing it, where you simply you convert it here itself. 300 meters is equal to 0.3 kilometers divided by 90. Once you convert that time into seconds, you will get 12 seconds for sure. All right. Okay, now question number 7 is the same thing, but the trains are moving in the same direction on a parallel line. Okay, they're not coming from opposite directions, they're not running towards each other, they're moving both in the same direction. Then what do we do? So two trains, 200 meters and 150 meters in length, running in the same direction on a parallel line, one at 90 kilometers per hour and another at 54 kilometers per hour respectively. In what time will they be clear of each other from the moment they meet? So similar to the previous question, except that here the trains are running in the same direction. So almost the same formula. You will add the lengths of the two trains divided by, you will subtract the speeds of the two trains. Okay, and make sure the units are the same. So in this case it is meters, so it is 350 meters or 0.35 kilometers divided by 90 minus 54, which is 36 kilometers per hour. After you will get the time in hours. After you convert that, you will get 38 seconds. Okay, I don't think I need to show you the workings. It's similar to what we did in question number 6, but just directly follow the formula. No further working is required. Number 8 is also same. Two trains of the same length, okay, but difference in speeds pass a static pole in 4 seconds and 5 seconds respectively. Okay, in what time will they cross each other when they are moving in the same direction and opposite direction? All right, so let us, here we have to do a little bit of workout. So let us assume that the length of train 1 and length of train 2 is x meters. Okay, so if assuming that the trains are now running in the same direction, total length is 2x, right? What is the speed of train 1? It will be x divided by 4 seconds, which is x meters per second, and speed of the second train is x by 5. That is the time taken by the second train. So if they are moving in the same direction, what do? We take lengths, add the lengths of the two trains divided by subtracting the speeds. So 2x divided by x by 4 minus x by 5. Once you simplify, you get 40 seconds. For opposite direction, you will do the same thing, except you will add the speeds here. Okay, and you will get an answer of 4 and 4 by 9 seconds for opposite direction, and same direction as 40 seconds. All right, now let's move on to question number 9. Question number 9 is also quite simple. A man covers a certain distance between his house and office on a scooter. Having an average speed of 30 kilometers per hour, he is late by 10 minutes. However, with a speed of 40 kilometers per hour, he reaches 5 minutes early. Find the distance between the house and the office. Okay, let us work out. Let the distance be equal to d. Okay, so let speed 1 is be equal to 30 kilometers per hour. Let normal time be equal to t hours. Let d be also in kilometers. Okay, so therefore time 1 when the speed is 30 kilometers per hour is given as they say he runs 10 minutes late. So it's 10. So it's t plus 10 minutes, which is equal to t plus 10 by 60 or t plus 1 by 6 hours. Here I'm converting minutes to hours. When the speed is 40 kilometers per hour, that is S2, what is the time taken? Is he's 5 minutes early. So it is normal time minus 5 minutes, which is t minus 5 by 60 hours, which is equal to t minus 1 by 12 hours. All right. So let us create two equations. D divided by 30, that is distance is the same, isn't it? So d divided by 30, that is S1, is equal to T1. Similarly, d divided by S2, which is 40, is equal to T2. So d in equation 1, once you cross multiply, you'll get it as 30 plus 5. In the second equation, when you cross multiply, you will get d as, and solve it, 40t minus 10 by 3. Okay. Now, you have to equate these two because d is the same in both cases. Once you equate the first and the second equations and solve it, you will get t as 25 by 30 hours. Okay. And once you substitute, what is t? T is the normal time. So once you substitute for t in any of the equations, let's say first equation, you will get the distance as 30 kilometers, which is the correct answer. Okay, they have used a formula here. So you can either use this formula or you will have to work it out the way we have done. I leave it up to you. Better to work out so that you will understand better. Okay. Now, question number 10 is similar to question number I remember doing this question where we were late by some question number 10. Yeah, question number 10 is similar to question number 9. Walking 3/4 of his usual speed, a person is 10 minutes late to his office. Find his usual time to cover the distance. Okay, again they've given you a formula, you can directly use it, you'll get an answer of 30 minutes, or you can work it out. Let's work it out. Let usual speed be s kilometers per hour, let usual distance be d kilometers per hour. Therefore usual time t is equal to d by s hours. Speed 1 is equal to 3/4 of s. That's what they have given in the question in kilometers per hour. Therefore t1 given the speed is equal to t plus 10 minutes or t plus 1 by 6 hours after conversion. That's what they've given. When the man takes 3/4 of his speed, he is 10 minutes late. That's what we are showing. But distance is the same, isn't it? So let us take the two equations and equate it. What is it? No, let us solve for time as asked in the question. So the time, that is distance divided by this speed, is equal to t1 by 6. So let us take, then solving for d, you will get this term. Okay, now now this is a term for the distance, right? But the normal distance can also be written as d divided by s, isn't it? The normal distance d can also be written as ts. So it will be ts or st equals this term, okay? Which when you open the brackets and solve, you will get this. When you solve for t, you will get, you will reach this terminology, this term, and then once you solve that equation, you will find t is equal to half hours rather, or 30 minutes, which is the correct answer right here. So let's move to question number 11. A train passes by a stationary man standing on the platform in 7 seconds and passes by the platform completely in 28 seconds. If the length of the platform is 330 meters, what is the length of the train? They have given you some working here, but I would prefer if we work out the problem. All right, so let's do that. So let us assume that the length of the train is L meters. Speed of the train, let us assume, is s meters per second. Therefore, let us form an equation 1 where we are given that the train takes 7 seconds to cross a man, right? That's what they're saying. Yes, to cross a stationary man. So we know that the time taken by a train to cross a man or a pole is nothing but the length of the train divided by the speed of the train, which is 7 seconds as per this question. Then it says that the train takes 28 seconds to cross a platform of the length 330 meters. So we know that we can write that situation as L plus length of the train plus length of the platform divided by the speed of the train should be equal to the time taken by the train to cross the platform, which in this case is 28 seconds. Once you simplify for L, you get equation 1, L as 7 seconds, 7s, not 7 seconds, s into 7, and equation 2 as 28s minus 330. We know that the length of the same obviously is the same in both cases. So when you solve these two equations, you get s as 330 divided by 21, right? Now let us substitute this in the first equation where L divided by s is 7 seconds. So when you solve for s, you will get 7 into 330 divided by 21, which is a speed, which is nothing but 110 meters, which is the answer given here. So that's it for today. Let's meet again for the remaining portion of time and distance topic. Until then, all the best and keep practicing. Take care.